Hello everyone, my name is Aman Kapat and today I am going to present my project title Hybrid Sparse Retrieval. This project is information retrieval system that combines two powerful techniques, TF and IDF and count vectorization to effectively retrieve the most relevant document based on the user query. Uh, to make it simple to use, I have also built a graphical uh, interface using Tkinter, so user can type a query and instantly see the most related document from a dataset. Let me give a quick example. Imagine you search for information about car. A normal keyboard-based system would you only find document that contain the exact words car. But what if another document talks about the automobile or vehicle? Those are still related, but the basic search might be completely miss them. My hybrid system solves the problem by combining TF-IDF, which understand word importance, and count vectorizer, which look at the how frequently word appears. Together, they make the search result more accurate and meaningful. In today's information-driven world, we deal with a massive amount of text every day from a research paper and the report to blog and online article. The main challenge is figuring out which document are truly relevant to the what a user is searching for. For example, if someone search for machine learning in medicine, there might be thousands of documents related to the topic, but how do you decide which one are the most important or most related to the user query? Traditional search method like simple keyword matching are often too limited. They only look for the exact word and don't understand the context or the importance of the word. That where more advanced and retrieval technique come in the project. I have combined two powerful approach, TF-IDF and the count vectorizer. TF-IDF gives more weight to the word and uh, that are unique or meaningful in a document, while counting vectorizer focus on how frequently each terms appear. By hybridizing them, we balance them terms importance and the terms occurrence and achieving better retrieval result. For this project, I use a publicly available dataset from Kaggle, the CISI information retrieval dataset. It contains a research paper abstract as a document and a set of user query. We store them into two CSV files, corpus.csv contain document ID and text, and the query.csv contain query ID and query text. These files act as our document database and the search query. Move on the code part of the retrieval system where I will explain how each component work step by step. Uh, First, first I import all the required libraries, OS, SOS for the file handling, and Tkinter for the GUI, and NumPy and Panda for the data operation, and skkit learn tools for the text vectorization. I also define the constants like data path, TF-IDF, weight, alpha, and the top K result to display. Purpose of each term. OS, SYS for the handling and system operation, Tkinter for GUI library, NumPy and Panda for data manipulation, and Minimax scale for normalization, scores between 0 and 1, alpha for controls contribution of TF, IDF, and counter vectorizer, and top K uh, used for how many top result to show. Next is data section, uh, where I handle data. The program download the CSS CI SI data set automatically using the Kaggle hub and parses the raw all and QRY files into the structured data frame and save them in the CSV. This ensure our document purpose and query data are always ready for retrieval. Now I'm going to explain retrieval model building. Now I created a TF-IDF vectorizer that capture terms importance uh, and count vectorizer that count the word frequency. Both are trained on the corpus to generate the sparse matrix and are representing the each document numerically. Convert text corpus into the TF-IDF matrix and use unigrams plus bigrams, single words plus two words phrase, output vectorizer trained models and matrix space numerical matrix representation. Build count vectorizer, same idea but based on the raw word counting, not TF-IDF weighting. Hybrid search, this is the core retrieval logic. Uh, Convert the query to the vector form. Uh, After that, compute similarity score using matrix multiplication, and after that normalize both a score and set between the 0 and 1. After that, combine a score using a weighted average, and at last sort and retrieve the top results. Now I'm going to explain GUI. So hybrid search A plus, it includes entry box for the typing the query, a search button, a scrollable result area showing the document ID and text. Uh, when you press search, it's called the perform search function and retrieve the top document and display them with the hybrid score. The GUI is responsive and clean and built it entirely in a Python. For example, top 10 result for query and uh, query is information retrieval. Uh, uh, After pressing suppose some document and a hybrid score is coming and that related all um, query is coming. Finally, the main function, everything together, it's and load the data, build both retrieval model and launch the GUI. The program then wait for the user input and letting you perform a real-time document search for the CISI dataset. Now I'm going to show live demonstration by running the code. This is GUI interface. If user press query information retrieval, then you press on search bar, top 10 top 10 result query is coming. Let's try with the another example. Uh, Information retrieval system. After that, you press on search bar. Top 10 result for query suggested. And coming to the advantage of this project, Coming to the result are the quite promising, and combining the TF-IDF and Count the Vectorizer improves the ranking quality. Documents that might have been missed by a single model are now better captured in the hybrid model. The advantage of the this project is balance the retrieval between the word and importance and frequency. Uh, s- Easy to deployment with TK Inter GUI work effectively even a large data set. This is the overall explanation of my project. Thank you.